Dear students, already in the previous session we have discussed some results based on planar graphs. Okay, so today we will discuss elementary subdivision and homeomorphic graphs. So what is the importance of this concept? Because already you know what is planar graph. So already I said a graph is planar if it is possible to draw on the plane without the intersection of edges. Then it is called a planar graph. Or you can say if it is embedded on the plane, then we can say it is a planar graph. Okay, once if it is embedded, it is called a plane graph. So that definition already we know. But how to characterize? What is a characterization for the planar graphs? Okay, so to know the characterization of planar graphs, we should know what you mean by elementary subdivision and homeomorphic graphs. So it's very important. So that's why in this session 21 we are going to discuss about these concepts. Elementary subdivision. What is an elementary subdivision? Here you can consider G as a graph. So this graph, what I have considered, contains some edges and vertices. Okay, vertices as well as edges. So especially if I consider the edge E equal to UV. So what I did in the graph G, I have deleted this edge E. So this edge E is deleted. Instead of this edge E, I introduced one vertex W. What I did? The same edge E equal to UV. In that I have deleted E. Then instead of the edge, I have introduced one vertex W. Then I have joined the endpoints of E, that is W with U and W with V. So it implies we are introducing one vertex in an edge. Okay, so in a graph, if you insert one vertex in an edge, or you can say you are deleting one edge, you are introducing one new vertex, and you are joining that vertex with the endpoints of U and V. That is the edge E equal to UV. So therefore, if you do that, what happens? You are getting another graph. So an elementary subdivision of a non-empty graph G is a graph obtained from G by the removal of some edge E equal to UV and the addition of a new vertex W and the lines UW and WV. So this is called elementary subdivision. So in this example, it is very clear that we have deleted one edge E equal to UV. Instead of that edge E, I have introduced, means we have added one vertex W, and we have joined the vertex W with the vertices of E. One vertex with the W with U and W with V. So it implies indirectly what we did in the edge, we have introduced one vertex, isn't it? So this is called elementary subdivision. So that is elementary subdivision. So what is subdivision? Subdivision means you can repeat this process for some other edges. It implies a subdivision of a graph G is a graph obtained from G by succession of elementary subdivisions. So in the previous example, we have deleted one edge. Instead of that, we have introduced one vertex, isn't it? And we have joined that vertex with the vertices of the edge E equal to UV. Here what we did, so in the same type, so instead of E, we have introduced W and we have joined with U and V. It implies indirectly in the edge E, in between you are inserting one vertex. So similarly for this edge, what I did, I introduced one more vertex. The same process, we have deleted this edge and we have added one new vertex and we have joined the endpoints of that edge. Okay, so like this you can repeat for one edge, two edges, like this three edges or all edges. It is not restricted. You may apply for one edge, two edges, three edges, like that. Okay, so whatever the graph you are getting after this subdivision, okay, elementary subdivision, or the elementary subdivision is continued for different edges. So whatever the graph we are getting, that graph is subdivision of the original graph G. Okay, so it implies in this example it is very clear that this graph is an elementary subdivision repeated for different edges. So ultimately whatever we got, this graph is a subdivision of the graph G. Very interesting and very simple also. Now we will see the other concepts. Okay, so already we come to know what is elementary subdivision, then we come to know subdivision, that is repeated process of the elementary subdivision. Okay, now we will see what you mean by homeomorphic from the graph G. Okay, see here, same thing what we did in the previous example, same graph I have considered. We got the graph H. How we got the graph H? We got the graph H by elementary subdivision. We have repeated for different edges. Ultimately we got another graph H. So a graph H is said to be homeomorphic from the graph G if either both are isomorphic or H is a subdivision of G. So both must be isomorphic. So for example, if I consider cycle is isomorphic to itself, isn't it? Like that. Similarly, you can consider this example. So this graph H, it is a subdivision of the graph G. So for that reason, what we can say, H is homeomorphic from G. Is it clear? So in the graph of figure A, H is homeomorphic from G. So we have discussed what is elementary subdivision. Then next we have discussed subdivision, means it is continued for different edges. Then whatever the graph ultimately we are getting after applying the subdivision, so that graph H is homeomorphic from the graph G. Okay, it implies H is obtained from G only. H is obtained from G only by elementary subdivision in succession. Okay, I think you have understood. Now homeomorphic with, that was homeomorphic from, now it is homeomorphic with. What is that? See here, example 2. G1, G2, G3, if you observe carefully, suppose G3 is the original graph. How we got G2? Just in the edge, this edge, we have inserted one vertex, we got G2. So G2 is a subdivision of G3. How we got G1? G1, again this edge of G3, we have inserted one vertex. It implies G1 is also a subdivision of G3. Here both G1 and G2 are subdivisions of the graph G3. So it's very clear. Okay, so therefore a graph G1 is homeomorphic with G2 if there exists a graph G3 such that each of G1 and G2 is homeomorphic from G3. Very interesting. Here G1 and G2 both are homeomorphic from G3. So for that reason G1 and G2 are homeomorphic with. Okay. So two graphs are homeomorphic with each other if they are homeomorphic from the graph G3. Okay. So this is how in the example 2 in figure B, if you observe carefully, G1 and G2 are homeomorphic from G3. So that's why G1 and G2 are homeomorphic with each other. So this is another simple concept. Okay. So now we will see if H is homeomorphic from G. Already we have discussed in the previous definition. Okay, if H is homeomorphic from G, then H is homeomorphic image of G. H is called homeomorphic image of G. While if H is homeomorphic with G, then H is homeomorphic of G. Okay, you know already homeomorphic from and homeomorphic with. Okay, so in general, we define homeomorphic graphs in the following way. So how to define a homeomorphic graph? Generally, we used to say this word homeomorphic graphs. Very interesting. Two graphs are said to be homeomorphic if one graph can obtain from the other by insertion of vertex of degree 2 into its edges. As we said in the beginning, subdivision of a graph. What we did in the subdivision of a graph? We have inserted one vertex of degree 2, or you can say in the edge we have inserted one vertex. What it implies? We have inserted one vertex of degree 2. Okay, so two graphs are said to be homeomorphic. That is, the graph G1 and the graph G2 are homeomorphic if one graph can be obtained from the other by insertion of vertex of degree 2 in its edges. It implies it is subdivision of the original graph G. Okay, so now in the example 3, already you know the figure B. Okay, in figure B, the graph G1, G2 and G3 are homeomorphic to each other because G1, G2, G3, we got G1 from G3, we got G2 from G3. So both G1, G2 are homeomorphic with G3. So in general, what we can say, G1, G2 are obtained from G3 by inserting a vertex of degree 2 in each edge. It is not compulsory in each edge, a few edges you can say, okay, into its edges in general. So therefore, in general, what we can say, the graphs G1, G2 and G3 of the figure B are homeomorphic to each other. Okay, so very simple concept. You take any planar graph, you insert one vertex between one edge. Means directly we are not inserting, edge is deleted, vertex is inserted, and those two end vertices are joined with a new vertex. It implies indirectly you are inserting one vertex in each edge. So that process is called subdivision of the graph. Okay, so any graph which is subdivision of the original graph, then that original graph and the subdivision of the graph both are homeomorphic with each other. So such graphs are called homeomorphic graphs. Now you can see another example here, very interesting example. Here I have considered three cycles. One is a cycle C5, another one is a cycle C4 and another one is cycle C3. Okay, so how we got the cycle C4? Just amongst one of the edges of C3, I have deleted one edge and I have introduced one vertex of degree 2 in that edge. I got C4. And how I got C5? In two different edges of C3, I inserted a vertex of degree 2. I got C5. It implies C4 is homeomorphic with C3. Similarly, C5 is also homeomorphic with C3. So, C4, C5, C3 are homeomorphic with each other because either they are equal or you can say one is homeomorphic from the graph C3. So therefore, these three graphs are called homeomorphic to each other. So this is very important concept, homeomorphic from or homeomorphic with. How we got? Just by subdivision of the original graph. So you may ask the question, why this concept is very important? Because we are going to consider a characterization of a planar graph. Already we have discussed a definition, but we want a characterization. What would be the characterization? Like that, the characterization for Eulerian graph, isn't it? So like that, what would be the characterization for planar graph? So that we are going to discuss in the next class. For that class, today's concepts are very useful. So you come to know today what is elementary subdivision. Okay, then homeomorphic graphs. Then we have considered examples on these concepts. Okay, so in this session we have considered elementary subdivision, homeomorphic graphs and examples based on these concepts. Okay, so it's very important to go through all these concepts, because in the next class we are going to discuss one important characterization. So with this we conclude today's lecture. Thank you.